Hello everyone, welcome to this new video on transformation of two-dimensional random variable part 1. Why we need a transformation? That's going to be the main question before we start our work. The transformation aids us for conversion of one kind of random variables into another kind of random variables. And this transformation will be useful when the things are going to be complicated in one space of working, and then after getting transformed into another space they may turn out to be an easy one. Or like when you have a sinusoidal wave, to minimize the losses and to increase their efficiencies, we can convert this sinusoidal wave into a digital format. So for minimizing losses, for maximizing the gains and so on, the aid is going to be transformation. So now let us see how a two-dimensional random variable can be transformed. There are going to be basically 6 steps for the transformation. The 6 steps are as follows. First, we will fix the auxiliary random variable if it is not being provided to us. The primary aim over here is to transform the random variable x comma y to the random variable u comma v. So there is going to be a transformation function f which going to aid your value or conversion of x comma y to u comma v. So if this secondary variable v is not given to us, then we fix it as say v equal to the secondary variable called as y. Then we need to check whether we have been provided with the joint PDF of the old variables x and y. If the joint PDF is available, only then we will be able to find the joint PDF of the new variables, which is going to be u comma v. So the joint PDF of the old variables x and y, if it is not being provided directly to you, has to be now fixed. The third one is, now I am going to transform the variable x and y to the variables u and v. So I need to know what is the relation by which my x is connected to u comma v and y is connected to u comma v. So if I know the relationship, then I will be able to compute the Jacobian of transformation. Why is this Jacobian required? Jacobian is nothing but the functional determinant of the partial derivatives involved over here, which aids for smooth transformation from one space to the other space and back to your original space. So how the aid is provided by the tool is going to be Jacobian over here. So we will be using the relationship which we have obtained over here, the x and y in terms of the new variables u and v, to compute the Jacobian value. Once all these things are done, the new joint PDF which we require is my f of u comma v. This f of u comma v is going by clubbing your step number 2 and your step number 3, like it is modulus of Jacobi times f of x comma y. Jacobi are computed in your step 3 and the modulus you have the f of x comma y we are computed in step 2. So put it over here. Now comes my step 5, which is finding the range space of u and v. Why we need the range space of u and v? Because we have now defined a joint function or a joint PDF, and this function needs to be specified for where it is going to be valid or the boundaries of the variables u and v where I am transforming it to. So like x and y has a space, and similarly u and v will also have a defined space where the function is valid. So I need to find what is going to be my range space. And furthermore, if the question requires you to find the PDF of u or v, then the marginal density function f of u or the marginal density function f of v can be just got by integrating the joint PDF which we have just now derived, that is f of u comma v. And we know that opposite poles attract each other. So if it is u, integrate with respect to v, and if it is v, integrate with respect to u. So this is going to be the basic 6 steps which will be required for the transformation. Come on, let us apply them to a problem and see how it works. The next problem number 1 says that if the joint PDF of x and y is given by f of x comma y is x plus y for 0 less than x comma y less than 1. We'll have to find the PDF of u equal to xy. So keep in mind the variables x and y are getting transformed to the variable u and v. So how is this old function f of x comma y given to us as it has been given to us as x plus y. We are going to now transform it to u and v, and what is going to aid us, the transformation function which is going to aid us is going to be u equal to xy. Now I am going to find out the new function f of u comma v, that is going to be our target. Now what is the first step in our 6-step format or transformation format? Fix the auxiliary random variable. We have been given with u, but we haven't said anything about the v. So what do we do is we fix the auxiliary random variable v as y. Now about the joint PDF f of x comma y. We'll have to check in our question if this has been provided to us. Yes, this has been provided to us. So we can directly make use of this function f of x comma y that has been given as x plus y for us. And this function has been defined for 0 less than x comma y less than 1. We'll have to be very careful about this range over here. The separator which is appearing over here is going to be your comma. You can see that what is separating x and y is going to be in comma. A comma in an two-dimensional random variable stands for the AND operator, which means x and y, both of them take values between 0 and 1. So this can now be transformed to 0 less than x less than 1, 0 less than y less than 1. So be careful about it. This is entirely different from that of saying 0 less than x less than y less than 1. We will normally get confused for over here. Here we don't have a less than sign, rather we have a comma over here. A comma says that both x and y take values between 0 and 1. So our step 2 is also done. That is, first step v equal to y has been fixed. Second step, f of x comma y equal to x plus y, the old function joint PDF is going to be got. Next, we move on to step 3. What is the step 3? We want the relationship of x and y in terms of u and v, because I am going to transform my x to u and v, and I am going to transform my y to u and v. What we know about from our step 1? From my step 1, I have fixed v as y. So I know that my y equal to v. So now this is going to be fixed. I have got one relationship. Now I have to fix my x. How to fix your x? What is the relationship or the transformation function you know about? U is equal to xy. You have been given u is equal to xy. What we require is going to be x. So x will be equal to, cross multiply this to the opposite side. So you will have u divided by y. So x is equal to u divided by what we know about y. Y we have just now fixed it as v. So I can write my x to be equal to u by v. In this case, what we have done now here, I have now transformed my x in terms of u and v and my y also in terms of u and v. Now we are ready for finding the Jacobian value of the transformation, for which I need the partial derivative of x with respect to u. When I differentiate x partially with respect to u, the second variable, which is v, is going to be my constant. So with 1 by v, I differentiate u partially with respect to u, which gives me 1. Next, I can differentiate x partially with respect to v. When I differentiate with respect to v, u is going to be treated as a constant. So 1 by v is going to be there. What is going to be differentiation of 1 by v? This gives me minus 1 by v square. So I have differentiated x partially with respect to v. Now moving on to y. I want dou y by dou u. Do we find any u in my v? No. In which case the partial derivative will be equal to 0. Next, moving on, what will be my dou y divided by dou v? With respect to v is already there. V with respect to v will give me the value as 1. So my partial derivatives have been obtained for the new transformed quantities of x and y in terms of u and v. So therefore we can compute the Jacobi value. Jacobi value is given by dou x by dou u. What we have achieved for dou x by dou u, it is going to be 1 by v. Dou x by dou v, what is dou x by dou v? It is minus u divided by v square. The next quantity is dou y by dou u, which we can fix it as 0, and dou y by dou v, which we can fix it as 1. So find the 2 cross 2 determinant of it. It is got by cross multiplying the opposite value and subtracting it from one from the other. So 1 by v times of 1 minus u by v squares of 0. So this will vanish, leaving you with just the first term. Therefore, the Jacobi value is 1 by v. So I now fix the Jacobi value as 1 by v. So my step 3 is over. Now we move on to step 4. What is the step 4? The new joint PDF of u and v. So I need to find my f of u comma v with respect to the Jacobi times multiplied by f of x comma y. What was the Jacobi value which we found here? It is 1 by v. So replace it as 1 by v. F of x comma y was nothing but the step obtained using my step 2. What is my f of x comma y? It is x plus y. Go and replace it over here. So it is x plus y. So I have now obtained f of u comma v. But we see a glitch over here that we want a function in terms of u and b, but we have the alien variable x and y. So what we need to do, we will have to transform this. Just now before, we have now obtained the relationship of x and y in terms of u and v. So go make use of this and replace the quantities. X is replaced as u by v and y is replaced as v. So multiply with 1 by v. Now we have entirely a function that deals with u and v. So this can be further simplified as, now let me take my v inside, so this becomes u by v square, and when we take my v inside, this becomes equal to 1. So my new function is going to be f of u comma v is u by v square plus 1. We move on to the fifth stage. What is my fifth stage? Finding the range space of u and v. How to get the range space of u and v? I need to begin with the range space of my old variable. What is my range space of old variables? So my old variables are x and y. What do we know about x and y? I know that 0 less than x less than 1 and 0 less than y less than 1. Now this is in terms of x and y, but what we need is in terms of u and v. And just now we have found out the relationship of x and y in terms of u and v. So what will this now get replaced as? X, you know, is going to be u by v. So this will be replacing x as u by v. And what do you know about v? Y is replaced as u v. So this is going to be my quantity. Now I can easily fix my range spaces of u and v. So from over here, cross multiply this v to the opposite side. So v into 0 is 0 less than u less than v into 1 will be equal to v. So I have my u to vary between 0 less than u less than v and my 0 less than v less than or equal to 1. So this is my range space of u and v. But we need to see diagrammatically how this is going to look like. So let us now try plotting the quantities in u and v as well as in x and y. So when we have the xy plane as well as let us have the uv plane. So let me mark this as x. This is going to be my y. Let this mark be as u and let this be marked as v. Why we are fixing this is we have already fixed y to be equal to v. So this will be more convenient way of expressing them. So this is my uv space and this is my uv space and this is my xy space. Let us plot the value or my range of x. So from over here, what do I take is the lower limit of x is x begins with 0 and the upper limit of x is x ends at 1. Next, the lower limit of y is y begins with 0 and the upper limit of y is y ends at 1. Now we will try fixing these four lines. Which is my line x equal to 0? My y-axis is my line x equal to 0. So this now I have it as my x equal to 0 and this now I have it as y equal to 0. So now I have found out the two lines which is going to be x equal to 0 and y equal to 0. Next is my x equal to 1. How will the line x equal to 1 look like? X equal to 1 is a line which is going to be parallel to my x equal to 0. So say suppose this is my line called as x equal to 1. And how will my line y equal to 1 look like? Y equal to 1 again will be parallel to y equal to 0 with 1 unit. Okay, so how much distance we have moved here? We will try moving over here also the same distance. So this will be my line called as y equal to 1. So I have my x equal to 1 and this is my y equal to 1. What is going to be the region enclosed over here? The region enclosed is going to be this square portion So this is going to be the space that is going to get transformed to. So I have my old space which is getting transformed to be obtained as a square. Now let us see how does this transform into the new space. In my new space, what is going to be the lower limit of u? U is going to be equal to 0. What is going to be the upper limit of u? U is equal to v. Now again coming to this space, what is the lower limit of v? V equal to 0. What is the upper limit of v? V equal to 1. We will try plotting these four lines. So now what happens over here is I have the line called as u equal to 0. Which will be the line u equal to 0? This will be my line u equal to 0. So this will be the same as this line. We will take it in the other color. It will be the line called as u is equal to 0. And which is my v equal to 0? So this is my u axis is nothing but my v equal to 0. So now I have fixed my two lines called as u equal to 0 and this is my v equal to 0. Two lines have been got. How will v equal to 1 look like? V equal to 1 will be line parallel to my v equal to 0. So let me draw this line for over here, which is going to be at 1 unit, say. So this is going to be my line called as v equal to 1. So my v equal to 1 is got. The one last line left out is going to be u equal to v. How to draw this line u equal to v? Give u as 0. When u takes the value 0, v also takes the value as 0. When u takes the value 1, v takes the value 1. When v takes the value 1, u also takes the value 1. So this line u equal to v passes through the points 0, 0 and 1, 1. So this is going to be the point 0, 0. Where will be 1, 1? This is 1 units over here and 1 units over here in my x-axis. So this will be my 1 units over here in u-axis. So this is going to be my point 1, 1. So if this is going to be 1, it is 1, 1. So how is this line u equal to v looking like? U equal to v is one that passes through these 2 points. So my line u equal to v will be of this format. So I have now plotted the line u equal to v. So this area enclosed by these closed lines is going to be given by what is going to be this new transformed area. This transformed area is going to be my triangle over here. Now you can see, fellows, that a square has been transformed to a triangle. That's the primary aim of your transformation. So now in certain case you can see like it is going to minimize the losses of transformation and it will preserve your signal, and it is something like it is going to be transformed in a compressed wave. Compressed wave means then the losses can be minimized for. So this is my range space which has been got for u and v. We will quickly move on to the last stage which is required. What is required is the PDF of u. What is PDF of u? F of u, marginal density function of u. How to obtain this? Integral f of u comma v, the new joint PDF with respect to the opposite pole, which is going to be dv. So this is going to be integral. What was the new PDF obtained? Go for your step 4. It is u by v square plus 1. So it is u by v square, u by v square plus 1, u by v square plus 1. This has to be integrated with respect to which variable? I have to integrate it with respect to dv. Now, the thing is that I have to fix my limits for v. Where do you get your limits of v from? From your range space. So, move on to your range space. You want the limit of v. How to fix the limit of v? Draw a strip parallel to your v-axis. Which is the direction of v-axis? This is my direction of v-axis. So my v starts from over here and it ends over here. So draw a strip parallel to your v-axis. Okay. Start from over here, it ends over here. So which is going to be the starting point of your v? V starts from u. And which is going to be the ending point of your v? It is v equal to 1. So where does your v move from? Your v moves from v equal to u to v equal to 1. So you draw a line anywhere in this green triangle, you will be moving from v equal to u to v equal to 1, v equal to u to v equal to 1. So this will be covering the entire of the triangle. So what we know is my v varies from v equal to u to the upper limit v equal to 1. So that's why we primarily asked you to sketch the region. If you're not sketching the region, it will not be easy for me to fix my limits. Okay. So now we have fixed the limits and we are ready for integration. So integrate your values with respect to dv, which is constant. U is a constant. So I'll have to integrate 1 by v square dv. and again one is going to be a constant. What is the integral of dv? This will give me the value as v. So this is going to be v, which is fixed, u into, now this 1 by v is nothing but v power minus 2. When I integrate, it becomes v power minus 2 plus 1 divided by minus 2 plus 1. So this gives me v to the power of minus 1 divided by minus 1. So I can write it as minus 1 divided by v plus v. Now this has to be applied between the limits. What is my limit of integration? My limit of integration is from 1 to u. Apply the limit for the variable. Which variable you have to apply? You will have to apply it for v. V takes the value 1 and u. So now moving on to the next step, I apply the upper limit minus u divided by 1 plus 1. So this is my upper limit minus the lower limit. What is the lower limit? Minus u divided by v is replaced by u plus u. So let me complete it. Minus u plus 1 minus of minus is going to be plus, u and u cancel off, leaving u with 1, and this is going to be again minus u. So here 1 plus 1, which is going to be 2, minus u and u is going to be minus 2u. So I can write it as 2 times of 1 minus u. So the function f of u is obtained as 2 times of 1 minus u. But again I say the function is not complete without defining its range. What is the range of my variable u? Go back over here. You know that your u varies between 0 to v. But I cannot write it in terms of v because v is the variable. When substituted, you will have a function of v. What is the extended range of v? V moves till 1. So where does your u vary from? Your 0 less than u less than v. But we can extend it till 1. So you strike off this v and you extend your u till 1. So you can vary between 0 to 1. So you can put a comma over here and write 0 less than u less than 1. So this is going to be my required function f of u, which is the PDF of u. I hope you got the steps clear. We will have a quick recap. So the first step is fixing the auxiliary random variable. Second one, fixing the joint PDF of the old function. Third step, find the relationship of x and y in terms of the new variable u and v. Find the Jacobi value. Fourth step, form the new joint PDF using the formula f of u comma v is Jacobi times f of x comma y. Find the range space of the new variables u and v. Fix it over here to get the PDF of the required variables u or v according to the question. Thank you.